To move toward not only what it is you know, but what it is you can do. And that's where I think universities can help train K-12 STEM faculty. How do you get kiddos to take it past the test, past the what do you know, and into the realm of what can you do with this knowledge? How do you apply this knowledge?
Okay. And then you will also learn how we can use nanotechnology to improve the efficiency of fuel cell, to make them smaller to be used in portable devices, to make larger, more efficient fuel cells to be used in industrial sector.
One of the primary reasons is the day and time in which we live. So much of our everyday lives are influenced by science, technology, mathematics. You're really disadvantaged to not be competent at a high level and able to understand some of the interactions that you have with the world around you. Something as simple as eating. You need a chemistry degree almost to read a food label with any understanding. And so the degree to which students or people can navigate the everyday world competently and with a decent knowledge base, they're better able to make decisions for their own well-being.
What is that all about? Cut us off?
Yes, whatever it takes.
I can't get to it, Tim. I can't get to it.
Get up there.
I can't get to it.
Come on, Jimmy Johnson. Come on, get out there. Go. Oh, it's going to get rammed. Good. Somebody's getting rammed. Stay out of my lane. Stay out of my lane. I also have set up use of borrowing a scanning electron microscope from the university, and have made a good connection through this workshop for that. So for 2 weeks, we should be able to check one out. And haven't developed lessons for that. Hopefully they'll have have training on the equipment first. So looking forward to that, and I'll probably use that in all my classes. So all my classes will have an impact from this workshop.
So you did all of these things?
Yeah. I thought of an activity where I can have the students cut up a square of a basic paper towel. Cheaper the better, so I want it nice and flat, very small thickness. And then cut up a similar square of a quilted tissue, or quilted towel, have them weigh it. You'll see there's a slight difference probably in the weight. The quilted probably is going to weigh more. But then drop them in trays of water and weigh how much water, find the weight and figure out how much water has been absorbed by the towel. Again, I haven't done this lab yet, but I predict that the quilted towel is going to be more absorbent and have more water and weigh more. And then one of the key things in math, and probably all kinds of problem solving, is explain why. You make the observation. As a math teacher, I'm trying to use the same things scientists do: observe and try to explain why what actually has occurred. But then they start realizing, well, wait a minute. If they had more weight on paper, it gives it, has more chance to hold more water. And we probably find some kind of percentage then how much more weight it had, maybe how much more water. And see, but then actually which one was truly more absorbent. The material might have been the same, but that little wafering, at least they can start to see that little small square, an indentation, creates a bigger surface. And it just goes right back to really how to increase the efficiency of solar panels.
I would say before I came to this conference, I really didn't understand how interconnected all the different disciplines are. When, I teach biology, so I'm so stuck in biology that I don't often get to interact with other, physics teachers or chemistry teachers. But when you're in a lab setting, no biologist just does biology. There's no physicist that just does physics. Everything is interdisciplinary and interconnected. And I really think that's something I can take back to my students who sometimes aren't sure what careers are available for them in science. So I really feel like I'm more comfortable talking to them now about potential futures in science.
My students that are taking physics to see the application in biology. So we talk about how red light has longer wavelengths and larger quantum dots, because they have a larger range of energy levels, will yield red light. And when you look at this mouse right here, this image, the mouse has a tumor because the larger quantum dots have attached to the larger cell. So I'm hoping to take my honors physics students and get them interested in taking AP biology. Those are a couple of things that I've been able to take away from the workshop this week. There's a few others with nano energy that I want to get involved with, but this is how I'm going to take it and put it in the classroom.
IUPUI has an urban mission, and I think we do that urban mission better than anybody else in the state of Indiana, and I think we're on a comparative basis with any other urban institute in the United States. And we're good in terms of STEM education and the STEM context because we've created some really high quality research centers. One of them is the STEM Education Research Institute, we call it SERI, in the School of Education. We have UCASE, which is the Urban Center for the Advancement of STEM Education. And we also have some research centers, CUME, in the School of Education as well. So we can do it about as good as anybody, and in terms of urban, we are definitely, I think, a state and world leader.